Hello and welcome to Hyperstition number 16, AI Accelerated CAD and Manufacturing. So my background as an engineer really is as a design engineer, as someone that is doing lots of CAD work, doing lots of finite element analysis simulations. And let me be the first to say, CAD design can be incredibly tedious. It's incredibly time consuming. It's incredibly taxing. And the last time I was doing this professionally, it was working with very complicated geometries for stellarator design and optimization. So a stellarator is a plasma configuration that has like a very organic kind of contour with no real easily exploitable symmetries. It's not symmetric in a single plane. You can't just reflect stuff. It has a weird Fourier space symmetry. So I was pretty desperate to kind of figure out how can I get more computational leverage on this problem. I tried FeatureScript and Onshape. This kind of sucked. I tried doing like scripting in Parasolid, which is like the kernel underneath Onshape and SolidWorks and a lot of other major CAD products. It's like an ancient kernel that is 30, 40 years old. And it's very difficult to work with. Basically, geometry kernels are responsible for a huge number of complicated operations that kind of have endless edge cases. Like geometry is actually quite difficult. And so that was also extremely painful and lame. And there was no good solution. But I think now there is. And it's a new company that is only recently launched. I think they've done a couple of launches, but now they have a much more mature kind of product out there in public. And the founder and CEO is with me today, Jesse Frizzell. Hello, Jesse. How you doing?
Good. Thanks for having me. Excited to be here.
Yeah, thanks for chatting. I appreciate it. So, what, in your own words, like, what are you building? What is Zoo?
Yeah. So when we originally started the company, we started with just the what we call the engine API, which is like the geometry kernel that and love or hate in your apps today. We kind of thought that would be the only product, but then we needed a way to dog food the geometry kernel itself. And so we built what we envisioned as our dream app around it. And then that ended up getting users and stuff. And it seemed like people really liked the ideas around that. And then as a part of building our app, we actually built a code language for interacting with CAD in a way that is like very simple. And so because we have that, we actually can use LLMs to generate models and stuff like that. And then we can have a lot of really cool machine learning features in the app. So it's a lot of different things for kind of like the AWS of CAD. In that there's like a GUI, but there's also the APIs behind it and everything that you can kind of stitch together in your own to create anything that you want.
Yeah, I think as like from me, humble engineer guy, like the big thing I thought would be super cool is even just having a twin between GUI actions and a scripting language, so that like I can click around and do fillets and extrusions and chamfers and whatever, but that's also building at the same time lines of code that I can then modify or to get like extensibility and scalability. Is that kind of how your thing works?
Yeah. No, we actually love that aspect of it. So everything you can do in traditional CAD, you can do with us in click and point, and then it generates the code like you said. And then even like if you just want to code your model too, you could still use click and point later. Like there's nothing that prevents that, which is really cool. And it doesn't generate shitty code. We like care a lot about that because there's a lot of like those HTML click and point apps where you like make an app and it's shit code on the back end. So we really made our language to work with a click and point interface in that it will generate very nice looking code that is human readable.
But then now, so you have a scripting language that's like well composed for doing CAD operations, but now you can train an LLM on that language. But I would think like a big issue there is like getting a like how do you like cold start the amount of training data you need to kind of make that perform well? Like how, like, you know, there's tons of code bases written in Python, whatever, to train from, not as many CAD models written in your language.
Yeah, that's a really good point. And with the earlier models, it was a huge issue. We had all these evals. We had this like how to write KCL as a Python programmer guide that would like feed the model so that it like understood it. But actually with the newer models, like I can like cold start Codex with our MCP, which has access to our docs and stuff like that. It can also search the internet for docs, and it figures out the language. It's crazy. A lot of what like problems it will hit today, just being like fully transparent, is that like it will try to do geometric operations in an order where like that's not going to work, and then it will just try again in a different order. And so we're working on fixing a lot of those bugs though, too, of the ones that we can, just so that it will like work on the first try. But like we do want the code to be written, or like the model to be designed in a way where if you do move a fillet later, you're not messing up the whole model. That's the whole point.
Yeah, totally. Okay, so this is interesting. So it sounds like you actually can kind of ride on the general progress and improvement in coding agent performance just by having your documentation, language characteristics, I guess, as like part of this initial prompt interface. Like you don't need to have your own coding agent from scratch.
Yeah, no, it's really nice that we can use like the large language models provided by like Anthropic or OpenAI. Like we eval all of them against each other, including Gemini. But yeah, like we're not in the business of making our own model. We like build the tools on top because what we're good at is the CAD and the tooling. So like by giving those models like access to be able to programmatically do anything on the geometry kernel, it's like very cool that it could like, you know, potentially take a cross section or take multiple views of a model, see like, oh, this face is here and this line is here, and then I move these things, and it's cool.
I think you're the only company I know of around that is actually trying to build a new geometry kernel. Can you help us understand, what is a geometry kernel? Like, what is it? What is this word?
Yeah, it's funny because I used to like do some stuff with Linux before. So like whenever people say kernel, I'm always like, that's so weird because it's not like an operating system. Yeah, it's more like we call ours like a geometry engine, but yeah, it's also referred to as a kernel. And so that controls like how all of this like renders, how it's computed, how it then exports back out, and like how surfaces interact. And because like there's things like Blender where that's all like triangles and it's a mesh, and you don't actually have like this surface like kind of interactions to be manufactured. Whereas like with us, we actually have everything about the surfaces so that you can then send it to a CNC machine or something like that and actually get the part manufactured. So all of that like computational geometry is owned by the CAD engine itself, and it gets into a lot of like weird math problems that are actually like impossible to solve, where you do have to rely on like really interesting algorithms to like gain speed or whatever over like existing algorithms.
And this is stuff like orientability of surfaces and determining like what the normal direction is and whether it points like exterior or interior to a closed volume.
Yeah, and like water tightness, and then how two surfaces, like two curved surfaces intersecting. Sorry, I do these weird arm motions. It's like one of the hardest problems to solve because it's mathematically unsolvable. Yeah,
it's like shockingly difficult, and it's probably why like I think the Parasolid kernel basically underpins like every major CAD platform today. So they all have the same computational abilities at its core. And then they just write like a wrapper on top of that.
Yeah, no, totally. And like, so we wanted to do the full stack. And that's why like when we started the company, we looked around and wanted to find someone who was basically doing this, but no one had the audacity to build the kernel. They were all wrapping Parasolid, which is unfortunate because like, if you don't fix the base layer, we'll be like having all these cool robots and stuff one day, but then the actual manufacturability of CAD will still be in these archaic workflows. That is just insane because they're bound by these 30-year-old kernels.
Yeah, that's interesting. I mean, and also it's kind of like you built the kernel from the ground up to be sort of AI friendly or interoperable, or I guess it's really because you need to have your own design language that you think is optimized for an LLM to be using, that's interoperable with the GUI operations. That doesn't exist otherwise. So it's kind of like you have to build this from scratch yourselves.
Yeah, I mean, honestly, we got a little bit lucky with like having our own code CAD language because like we weren't optimizing for LLMs when we started. Then like GPT, I think it's like 3 or 3.5 or whatever came out, and it was decent. And we were like, oh, okay, shit, like maybe we can use this to generate code. And it just kind of worked out well. But yeah, we were already like programming language nerds. We kind of had a lot of audacity to just be like, let's make the kernel in our own language and all this shit on top. But it worked out well with the ecosystem and where it was going.
And I'm curious, how far? I mean, so we all have this like image in our collective imaginations of like Iron Man, right? Where he just like talks to his computer and it's just like designing stuff and making all these tweaks and stuff like that. How far away is that in your mind? Like basically, what's the state of the art for you guys right now? And sort of just like a plain natural language description of something that can then generate a reasonably well-constructed CAD model.
Yeah, so we see improvements with every like large language model that comes out. So like Codex 5.3 came out and they don't have it in the API, so it's not in our app yet. But like we've been playing around with it like through like the Codex CLI and stuff, or the GUI that they have, and it is honestly like a step change in that like one of my colleagues he just like would upload a picture of a burrito and it would make a model of burrito, and like honestly stuff like that, and especially a one shot like we hadn't seen before. Like I'll use a lot of like iterative prompts to get somewhere, and I will say as long as you describe it right, it will usually do what you want. But like for it to like one shot like a stupid CAD model of a burrito, or like he also uploaded one of the turrets from Factorio and it did it. And so it's just like crazy to see like the improvements with each of these like new models that come out. So it'll only get better over time.
Yeah. And this kind of like, in my mind, this kind of like melts the whole like Byzantine nightmare of like SolidWorks parts libraries and parts management stuff. Like, you know, in a big organization, tons of people designing stuff, like you have standard things that you can define a few key controlling variables that can regenerate geometry, but then it's like a nightmare to get these to play well in assemblies. You have all these broken, missing mating references. I stopped using SolidWorks for that reason and tried to use Onshape, but it's like way more of like a, I don't know, kindergarten level design environment. You know what I mean? It's like it's not as good. And then on the other side, you have like, I guess, CATIA, Siemens NX, which are like, you could design a whole building in a single environment, but they're like, the learning curve is quite high to use those tools. I'm curious, where do you think Zoo fits into this CAD landscape in terms of like, who like, where would it be the best high leverage application to use it for?
Yeah. So right now, like our customers are in like aerospace or automotive, but I do think like any industry should be able to use it. We don't have surface modeling features yet, but we are getting there. And like within the next year, I will say like a lot of the enterprises are interested because we can take any proprietary CAD file from any of those apps that you just named. As long as it has a feature tree, we can convert it to KCL, and that's like deterministic. There's no like machine learning in there. We actually use like, once we get out the like raw code, we'll use like a model to refactor it or whatever. But yeah, the actual code itself is like, it preserves your design intent. And so they can actually take all of their existing CAD files, convert them to our app, and then like we can use it in trainings, but we can also use it for like if someone's just like at their computer and they're like, hey, I know there was a gear that we used in this thing once, and it was like maybe part number this, or maybe they don't know the name, but they can describe it and it can bring it up and be like, you're talking about this gear or this gear. And then like part reusability is like way nicer when things are functions or, you know, a library exists.
Yeah. I would think this is extremely cool when people are like designing iterations of a thing, and they're more interested in like a few key control parameters that are perhaps informed by simulations, but then there's all these like connecting elements that have to get regenerated around that, right? So is the idea here that you can really just be like, I mean, my perspective is basically it's the feedback loop from this mechanical design, the tolerance requirements, the materials you can use, and the machining limitations, to have that then connect to simulations environment to feedback. And that's like a really time consuming, tedious thing right now, where I am personally exporting like CSVs from console or something like that and trying to like map them. Like, I'm curious, have you guys thought about this like simulations integration?
Yeah, so a lot of this I would just figure would be a tool that the model can use. Just like we give it tools to use the geometry engine, you would have a tool that calls out to whatever your simulation tool of choice is. We have no plans right now to make a simulation kernel of our own. But like if you had a way of programmatically interacting with that simulation tool, you could actually do this iterative loop where the agent, just like you would in like a code thing, it would like modify code, it would run a test. And then it would like iterate over and over until whatever your simulation is, if it's like withstand the force of 50 pounds, until that passed. And with all the other, tolerances that you give it, whether it's like, this also needs to be like CNCable. And there's a lot of stuff that we can do as far as linting the code to be like, oh, you know what, this hole is too tight, a drill won't fit through it. Or like, we can't, said you have a 3-axis machine, something's not going to be able to fit in there to get to this like surface or whatever. So there are like some like cool code things we can do in the future there, but all these things can interweave where like if the agent just reaches out to all these tools, they can do all of that for you.
So I'm curious, something you just said, are you actually building this so that I can define downstream, like what are my manufacturing methods I have accessible, and then that informs how the CAD models are generated by an AI coding agent or something? Like I don't have to like hold that in my head necessarily.
Yeah. So I will say like today you could ask it questions about like, how will my model work like on a CNC machine? We were like talking to some people from Form Labs the other day and we inputted their PDF of like DFM and we were like, will this model work or how should I orient it? And it read it and then it like gave you some output of like how you should fix things. And so there is like some stuff there, but the tooling and stuff will only get there as we make things like more and more first class and where there's more, instead of just like relying on like search and finding, there's more like actual deterministic tools involved that make sure that these things are safe for that machine or whatever.
So this is kind of like, I mean, if I'm a small, medium-sized business making parts or I have a startup or something, like I can just like tell you, these are the machines I have. You have knowledge of my parts library, my assemblies, and it can be like, now I'll just define, I want this metal beam to not have an internal bending stress greater than this amount. And I need to reduce its material size and change its configuration. Hypothetically here, your system could both interface with the simulations output, update the CAD model, and have that be producible given my current equipment.
Totally. And then honestly, if your machine had a nice API, we could send it to the machine. But the problem with a lot of these things is that like for Bamboo Labs, for example, we had to reverse engineer the API inside our office because like we wanted to like send stuff to it. Like a lot of these things are just not set up for that. And so it's like bringing an archaic ecosystem through to the future as well. But yeah, like that's the end game is like all these things have programmatic access to them and we can just call out to it.
Yeah. Well, I don't know if you want to comment on this. I've seen a few like companies at YC and other places that are trying to be like text to CAD and whatever. What do you think they are missing? Or I guess, because I've seen other like this problem that designers spend so much time just translating their intention into some kind of machinable drawing or even a maintainable assembly. It's huge. It's a massive bottleneck. So what do you think other companies are approaching this that they are getting wrong?
So I think there's like twofold. One, they're just focused on the text to CAD problem, whereas we're an entire CAD platform. And then like two, like a lot of them, I mean, 90% of the ones that I've seen, maybe even 95 or 99%, they're all mesh. And so sure, like if you want to look at people using a 3D printer, you're good, but there's the entire like manufacturing ecosystem that exists, and that's just not going to work.
Yeah. For people that are curious, there's really three types of, well, maybe you can correct me if I'm wrong, but there's kind of three types of, I guess, digital representation of physical objects. There's meshes, like SDLs we use for 3D printing. That's like a triangulated surface, basically. There's the boundary representation model that's used in like parasolid kernel, where you have like arcs, curves, some parameterized surfaces that are like forming this. It's kind of like the difference between like a PNG or a pixelated image and a vector representation, where it's like the boundary representation can maintain the high fidelity. And then there's like this third super weird one, which is like implicit mathematical representations, which I think is end topology. That's what they use, which I know you can do crazy stuff like some kind of like metal foam heat exchanger type thing that has like crazy surfaces and stuff. Is there, in your mind, like you guys have a boundary representation model internally, right?
Yeah.
Is there any niche that people would be, I mean, designing CAD objects using something that's not that?
So, I mean, we see people use things like NTOP, which for those who don't know, that's like implicits. I will say, like, I do feel like there is this like little implicit versus like B-rep community where like the implicit guys have it easy. That's, I mean, I don't want to say it's easy, but like those are all mathematically solvable problems. We have the non-mathematically solvable problems. And so, yeah, like what you get from that is a mesh. And so like you really have to be careful basically where you're using those kind of tools, because if you intend to use it on certain machines or whatever, or if you want to go back and edit the feature tree afterwards, you just can't. And it's not in a, you know, the kind of SVG like workflow that you want, where you want to like edit the high fidelity surface.
Because I mean, that's like, you know, design perspective. It's like, I want this radius of curvature on this part. I want to control parameters that generate my feature tree, my finish, my finish thing, in terms of like these human readable components that are like what you'd set up the machine to do. You know, people don't really think in terms of like implicit mathematical surfaces outside of like perhaps optimizing or importing a geometry that's already been designed.
Totally. No, they're like really weird alien-like structures. People do like it for that like vibe, but yeah, they're like, it would be non-human readable. Like if you had a diff that you wanted to review, which we care a lot about, like looking at the changes and stuff like that, it would be nearly impossible because it would just be a whole bunch of floating points.
Yeah, totally. So I'm curious, what's like top of mind for you right now in thinking about like, where is the Zoo CAD sort of platform at versus where you want to take it next? Kind of like, the company's, I think, about 2 years old?
We were founded in, I'm going to fuck this up, I think it's like 2001.
What?
Yeah, we spent a long time building that like original geometry engine.
But you said 2001?
Oh, 2001. Sorry. Yeah. Or no, 2021. Sorry.
2021.
I knew I was.
Okay, that's.
Yeah.
I was like, you're 20.
Not that long, but yeah, like
5 years old.
Yeah.
Okay. 2 years old. Yeah. Cool. Yeah. So what's the state of affairs right now? Like, what's like, you know, in terms of feature development, in terms of like performance capabilities you want to work on next?
Yeah, so we do have a lot of like, when we started the company, we wanted like a very, very fast CAD kernel. And I will say the potential that our CAD kernel is versus what it is today is like, we have so much low hanging fruit because we've mostly been working on like, oh, someone says that they want, you know, surface modeling, or someone says that they want this like feature or whatever. So we've been focused there versus on speed, when like we all care a lot about speed and there is a lot of low hanging fruit we could do. So I will say like, there are some like roadmap initiatives internally to make the speed a lot better. We're also getting surface modeling and a lot of the like, you know, interfaces that people are used to using in different industries. And yeah, stuff like sheet metal, all of that. And then, yeah, as we go from there, like, I think that we'll have a lot more interfaces, like I was saying, for like the agent talking to different tools, whether it's like your simulation tool or DFM tools. And then you can kind of integrate all these things together and just have the model make things for you, just like you would set up with like code stuff and MCP servers. And yeah.
Totally. Does it make sense to build your own simulation engine, like finite element solver or like a CFD solver?
So I don't think so personally, but also like, okay, so we had one of the reasons why we did the engine itself when we started, I would say it was like a mix of like overconfidence and naivety. And now like I have learned that. And so I'm not making that mistake again, where like, we know that's a hard problem to do a simulation engine, and there are other people doing it. And also like, I do feel like as much as people like really hang on to their like CAD tools, they hang on to their simulation tools even more. Because yeah, with CAD, when you're designing, obviously it needs to be watertight. Obviously you need to trust the math and that things are actually going to work. But if your simulation engine then fails or like has a weird bug or something, like you're totally fucked. And so people like do not tend to change those very easily. And so it's a market that I think is entirely hard to crack. But if it comes down to it, like years and years from now, and we decide that we want to, I'm not saying we will never, but I would need a stroke of overconfidence again to do that.
That makes sense. Like to check that your part was made correctly takes like calipers, right? To check that your simulation worked correctly, like you have to build the device. So that's like Fusion. It's like that costs $1 billion. So you spend all your time in simulations and design because it is a build once thing to make it work, essentially.
Totally.
Yeah. Cool. Well, how did you, I'm curious, because when you casually mentioned you worked on some stuff in Linux, I think that was somewhat of an understatement. I mean, you have a pretty solid software development background. How did you end up getting roped into this world of geometry kernels and mechanical engineering?
Yeah, so my previous company, Oxide, we were building rack scale servers, and they're still like going strong. But like that was my first time using a CAD tool at all, and so we were using SolidWorks, and I was on a Mac, and so I opened it up in a VM, and it was just like loading our entire rack, which had like everything down to the resistor and the boards and like all this stuff. It took forever, and I was like, oh, this is because I'm running it in a VM on a Mac, and so I get out like my Windows gaming rig, and I like open up the file. And it's just like slow as shit too. And I'm like, is the GPU not running? Like, I'm so confused. And I started looking into it. I realized that's single threaded. And then there were all these other things that I wanted where like, we had industrial designers, and then we had the mechanical engineers, and the industrial designers would change like a hole or like the logo placement on the side of the rack, which was like, it was cut out of sheet metal, and then they'd give it back to the mechanical engineers, which like days would happen, and the mechanical engineers would be like, no, like you just move something, now it's going to be too hot, it like the simulation will break or whatever. And I'm like, this is a fucking pull request. Like you make a pull request, you change something, a simulation runs, and then you get your feedback. We don't need these like people passing files back and forth. Like, what the fuck is this? So yeah, I like was looking for something else, and then one of our now co-founders, Jenna, introduced me to Jordan, and I asked them what they were using for CAD relativity at the time. And then we just started ranting about how bad CAD is. And then we got here where we had to solve the problem because no one else was doing it. So yeah. Yeah.
That's hilarious and awesome, because I think like the broader trend here as well as like, I mean, zooming out for a second, like software companies are kind of getting wrecked, you know, like public equities markets and stuff like that. More and more people want to invest into hardware, but it's like, how do you actually speed up the iteration time in hardware industries? And like the CAD simulations is such a bottleneck, because it really is, it hasn't really evolved past like point and click manual operations for the great majority of things, right?
Yeah, and then you have your PLMs, and you have like all these steps that are just very human oriented, where like this could be, I mean, honestly, I was just surprised because coming from like the world that I worked in was like software infrastructure. It was like, you know, like you have a CI system for everything. If you don't like automate something, you're stupid. And like if you're fixing the same, if you're doing something manually twice, that's also considered dumb. So like all these processes, I was like, what the fuck are people doing? And so it just seems, especially even now, more so with AI, it seems ripe for automation. Yeah, you can't programmatically talk to something. Honestly, like the AI stuff that like clicks and points is pretty crap. I don't know if you tried it, but like the programmatic access is like essential.
Yeah. Well, it's like software developers, they build the tools they use. Like they use software programs and environments to write code, to develop, deploy features, but they also write the same stuff behind that. So there's like this natural like confidence, like, oh, I could write a better editor. I could write a better extension. I could, you know, so it's like they make their own tools better and better themselves, because like they are both the users and producers of the same thing, which is software products, right? Whereas mechanical engineers, like they don't write code typically. I mean, maybe now they will more so, but they design mechanical objects. They're in the world of fasteners and tolerances and thermal dissipation rates and conductivities, all these things. And so like they are like, we need to like rescue them from this world of like shitty legacy software that is built by people who don't care about your quality of life. Like, you know, I don't know. Like I have this view that, like if you look at ANSYS and the interface for ANSYS, it is from like 1998. It looks like software from like a previous decade.
Yeah, no, like a lot of these have like really, they look like Qt, like that's like the framework they all use.
Yeah.
No, they're absolutely awful. I feel bad because every single mechanical engineer that we've had join the company, we break and then they start writing code and we're like, oh shit, no, like you need to give us feedback on the stuff that mechanical engineers care about, which they do. But like, we never want to lose track of that, like original mechanical engineer, like just trying to do the things that they do in the workflow today, because we just won't succeed also if we don't like meet people where they're at and also bring them along for the ride into the future. And yeah, also we never want to do anything that like is just like stupid in mechanical engineering.
Yeah, I feel that. Well, people like mechanical engineers have like a richness of design intuition that understands like how to like how, you know, what kind of surface tolerances you need. Like they understand implicitly like all of these things downstream that can really affect things, like whether something has like a thou tolerance versus like 100th of a thou. It's like, oh, that's 1,000 times more expensive to machine or something like that, right? Like, so take all their design intuition, their knowledge and their experience and, you know, apply that where it's highest leverage, which is really just like, how do I get this into a digital representation or some kind of embodiment that can be shared with other people versus, no, you have 80 years of experience and 90% of your time is like clicking on context menus.
Totally. No, like, and that's like what, like, I think a lot of the software engineers on our team have come to value about all the mechanical engineers, because like, take it for like example of myself, I'm a good software engineer, but I'm like a shit mechanical engineer, where I tried to make this like little, the Bamboo Labs 3D printers, when you use them, they kind of have this like poop that comes out that's just like filament. So I wanted to make this poop shoot. So like the poop will come out and then come along the side. And so I got this like model, and then I showed it to Jordan. He was like, this is going to take like 2 days to print, like just fucking model it differently. And then it takes him like, and honestly, like, I feel like it probably took me like forever to make that. And then he's just like, let me fix it. Every time that I have a model that I know is shit, I now show it to Jordan because he'll just fix it. But yeah, like he knew automatically that everything I was doing was stupid. It was going to need a ton of supports. He made a way better one in like 5 minutes. So yeah.
There's an analogy here between like object-oriented programming methods and like CAD design and like producing a good feature tree, because you want something that can be like maintainable, that has a logical construction in terms of like order of hierarchy, so that like if I change something down here, it doesn't break a bunch of unrelated stuff, like depending on how you dimension stuff. So we have, because we're doing this live, we have questions from the audience. Do you want to answer some questions from the audience? Yeah, okay, cool. So can your CAD kernel address joints, contact surfaces, and stresses on contact surfaces?
Not today, but in the future we could do that. When it comes to stresses, though, I think I would leave that more to a simulation.
That's kind of a simulation thing, yeah.
But yeah, I will say today, like, we don't even have like assembly mates. You kind of have to like move things next to each other if you want them to be side by side. But we do have like multi-file support, so you can do assemblies, but mates are coming soon.
Yeah, I mean, that's my experience too with the deformability and sensitivity analysis. It's like you need to be, you need now an FEA engine that can compute internal stresses, strains, whatever, to find out how things deform. Another one from Ben Bohm, who I actually know. Hey, Andrew and Jess, do you think AI native CAD will change not just how we design parts, but what kind of parts are even thinkable?
Oh yeah, I mean, that's interesting. I probably, honestly, because well, as a non-mechanical engineer myself, I don't know what a lot is possible, and so I feel like all the time I'm making stuff that isn't, but it's probably super basic. But I do feel like the mechanical engineers on our team make really cool stuff.
I guess the question is really like our brains are only so big. right? But now you have like the latest Codex model, the latest Claude Code model, like, and they're pouring billions of dollars into making those things as good as possible extremely quickly, all these data centers and stuff like that. So you ride on top of this. How long before we have sort of mechanical assemblies being designed and manufactured that I guess like no person could think of? Like it's sort of.
Yeah, that's interesting. It's like an Erdos problem of CAD, which like I'm sure people have thought of things like that are just like uncadable. I've seen the ones that are like very hard to manufacture that are like going around as like rage bait. But yeah, it would be really interesting because I bet there are even like designs that are more efficient that maybe no one's ever thought of.
Yeah. I mean, this like geometry space, it's like, so it's, you think of it's only 3-dimensional, but it's how things work is much higher dimensionality than just that. Like the number of ways of like optimizing a chassis or a carriage or rethinking things. So eventually, I mean, you know, the sci-fi future here, it's I pay you guys a monthly license fee, and then I just like talk into a microphone like a CAD, like you're my CAD therapist, and I just kind of say like, you know, I'm sick of our version 1. It sucks. I need to make it more. You know, we need to sell our 5-axis now. We need to make this in a simpler way. And you guys just like, I guess end to end then for Zoo, like as you mature the feature base, what do you think of as like the mature input and the mature output, and like kind of where you stand from like, I have a design intent, I want some finished thing?
Yeah, I think honestly in the end game, it's like you get the physical part. Honestly, like you have a design intent and then you actually can get the thing, whether it's like printing on your own, you know, machine that you have in-house, or like sending it out to something like Send Cut Send. I think that like that would be the coolest because you don't have to intervene. But of course, like it will go through lots of phases before then where, you know, mechanical engineers will probably look at the model and be like, this feature tree is slop. You know, or it can't be made right away. But like, honestly, every rev of the models, we see vast improvements in how it even like thinks spatially and stuff like that.
Does it make sense over time to kind of like start gobbling up some of the manufacturing side too? Like, would it make, like, from your guys' perspective, like, because you own the design simulations iteration feedback loop, like the next value capture point is like running a machine shop that people send stuff to?
Yeah, I think it would depend, and we'll like cross that bridge when we come to it. But
Sure.
I mean, I do foresee us being like a huge business at the end of the day, and like I said, we could even eat simulation, but like we're not planning on it today. But like if it came down to it, and like we couldn't get, you know, to where we wanted to be, it would just be like all over again. Oh, we have to do this ourselves or whatever.
Do you like, you know, do you miss just working on normal software stuff?
No, I actually really love this. I get bored if I'm doing the same thing. And so there's like an endless possibility of weird shit that we hit that like, we'll have really weird bugs where like me and like the other software engineers on my team will like nerd out about how crazy it is because it was just like this thing was rotated weird or whatever. And like get into the spatial aspect of things, you just hit problems that are very like intellectually stimulating, I would say.
Yeah, this is the foundational like shape rotation activity, right?
Yeah.
You know, so this is like this is the final frontier of shape rotation, is we no longer have to rotate our own shapes.
Yes, for sure.
That's awesome. Cool. Well, what's you know, while we have an audience, while we have people watching, what do you guys need? Are you looking to hire certain things? Are you looking to like expand the team, find customers? Is there a way for people to try this out?
Yeah, we're always hiring. Also, our app is free. You can use it on the web or download it and try it out. We have a free tier where you can like play around with the AI tools all you want, and well, all you want up into a limit, and then you have to give us money. But yeah, so give us feedback. Tell us what you like, tell us what you hate, especially because we'll make it better. And yeah, it's still early days. I mean, it will be early days for like the next 10 years, probably, as we continue to build out like the supervision. But it's there's a lot of cool stuff to do. And we're always hiring great software engineers, great mechanical engineers that get it. And hopefully we won't convert you into like learning how to code.
I mean, that's not such a bad thing, because it can simplify your life so much. But I guess for you guys, like, you don't have to learn how to code; it can write the code for you. End of the day,
Totally.
right?
Totally.
Yeah, totally. So mechanical engineers can just be the artists that they truly are internally, and not get bogged down. Well, that's awesome. And yeah, I really wish that your product had existed when I was a mechanical engineer. I can just say this from the heart, because there was so much tedious nonsense that was required to do basic things in a programmatic way.
Oh, thank you. That's really nice. Yeah, we hope to live up to everyone's dreams of the best CAD app ever.
Yeah. The Iron Man Jarvis design me a better suit.
Yes, I want that.
Cool. Well, I'll let you get back to your own zoo of animals in the background. That sounds awesome.
Oh yeah, sorry.
That's all. Well, you got 3D printers, you got zoo, animals. It's great. It's perfect. Jesse, thanks so much for your time. Thanks for joining us.
Yeah, thank you.
All right.